Hello, welcome to this continuous integration course with Teamcity. This course is focused for users of Teamcity, so it does not cover any of the administration related parts. Before we begin, let's define what continuous integration is. Back in May 2006, Martin Fowler defined continuous integration as a software development practice where members of a team integrate their work frequently, usually each person integrating at least once a day, which can lead often to multiple integrations per day. Now, each integration is verified by an automated build process, including tests, to detect integration errors as quickly as possible. So what exactly does this mean? Well, let's take a look at a typical scenario when we're building applications. Often, we're faced with a software system that's composed of different components. We have one person working on component 1 and another person working on component 2. Each of these people in isolation have the code and the unit tests, and everything normally works out great. They write their code, run their unit tests, and it's all fine. The same happens with the person working on component 2. The problem is, however, that software systems aren't composed of individual and isolated components, but they are composed of components that normally have to work together. When we're doing teamwork, we often have source control, and we have different members of the team working and checking in their code to source control. And in principle, if everything is done correctly, all is good. The first person checks in the code, the second person checks out code, and everyone can continue to work in a normal way. However, reality tells us that things don't quite work as expected. Often, we end up where one developer checks in some code, and although the code that they were working on works perfectly, since components are normally meant to work with each other, the code that they check in can have side effects, causing other components to break and thus interrupting the workflow and the process of other people. As the other members of the team check out code, things can break. In a continuous integration scenario, what we can do is we have a thing called a CI server, which pulls source control. When the first developer checks in some code, the CI server gets notified that some code has been checked into source control and performs a series of automated builds and running of unit tests. It then delegates this process to some build agents, which can be either virtual or physical machines. And once these build agents complete the build process and run the unit tests, then they notify the developer, indicating whether the code that they've just checked in has been successful or not. What this prevents is other people checking out code that potentially has broken the build. If something is broken, since all developers on a team are usually notified of the status of the build, they now know that they shouldn't be checking out the code until they get a successful build. Notification can occur using different mechanisms such as email, a tray icon, growl notifications, etc. Where does Teamcity enter the picture? Teamcity is this CI server that we've been talking about. It takes care of automating builds and deployment process. It increases the quality and the standards across teams by preventing broken builds being committed or notifying team members that there is a broken build. It acts also as an artifact and NuGet repository, which means that the result of a build can be available to other projects and to end users. And it also provides reporting and statistics on builds and the overall workflow of the team. And last but not least, it supports a variety of platforms and technologies. Here is a simple diagram showing all of the different technologies that are supported, from different browsers to different version control systems, development frameworks, both in Java, .NET, as well as Ruby and others, different build runners, different unit testing frameworks. It is quite heterogeneous in what it offers. Teamcity is a web application. As such, it runs via the browser. The browser is your user interface. It runs on Java. It's a server-side application running on Java. As such, it could be installed on a variety of platforms. And it integrates with many technologies and platforms. When you first access Teamcity, you're presented with a login page. And you can log in as a guest user, or you can log in as an authenticated user, where you get a different set of permissions based on how they've been assigned to you, allowing you to access different projects or different configuration items of the project. The main screen basically lists a series of configured projects, and we can access our changes, a list of all projects, agents, build queues, etc., all from here. After logging into Teamcity, we're presented with the overview page. Now this is basically our home page. This is where we work from. We can access projects from here, access our changes, access agents, build queue, as well as update information about our profile and tools, etc. Let's take a look at projects. In order to access a project, we can hover over to the drop-down arrow next to projects, and a list of projects will be displayed to us. We can scroll through or just type the name of the project and navigate directly to it. We can also access this drop-down list by pressing the P button on the keyboard. If we type the name of a project and hit enter, we can then go directly to that project's homepage. Before going further, let's just describe what a project and a build configuration is in Teamcity. Here, for instance, we have Kotlin, which is an open source language that we're developing at JetBrains. Now, Kotlin in itself can consist of multiple sub-projects. There can be the compiler and plugin, there can be a library, which is, for instance, Kannotator, etc. In Teamcity, we can have a single project, and inside this project have multiple build configurations. A build configuration can correspond to a sub-project, for instance, a compiler and plugin, in this case, but it can also correspond to a specific configuration environment for a specific project. For instance, I could have a build configuration that refers to a production release of the compiler and plugin, whereby it does not have debug information or certain level of logging. And I could have a build configuration that corresponds, for instance, to a test deployment of the compiler and plugin, where it does have debug symbols and certain integration tests, for instance, are not executed. So not only can we have a single project and then different build configurations corresponding to different projects, but we can also have a build configuration corresponding to a sub-project, but with different settings for that build to run. Here in this case, we can see that the Kotlin project has a build configuration called compiler and plugin. It has another one called compiler and plugin idea, it has another one called Kannotator, etc. And each of these have their actual run of the build configuration. Let's go back to the overview page. Now, what we would ideally want to happen is that when we log into Teamcity, we see the projects that we're interested in. And we can do this in Teamcity by configuring visible projects. By clicking on the link, we can see a list of all hidden projects and those visible on the left-hand side. We can select those that we want from the right-hand side. For instance, I will select Amazon API Client and IntelliJ IDSCE and move them over to the left. I can also look for a project by typing its name. And I can also reorder the projects on the left-hand side. So for instance, I can say move Kotlin all the way to the top. When I click Save, Teamcity will now display those projects for me and only those projects when I log in. I can still access all of the other projects by going to the drop-down box, but by default, I now see the projects that I'm mainly interested in. At any time, I can change this configuration by clicking on Configure Visible Projects and add or remove more to the list. On this project page, we can now expand or collapse a specific project by using the arrows, or we can collapse and expand all projects by using the buttons at the top. Collapse all will collapse all, and expand all will expand all, including all of the build configurations. On each of these projects, we can see that on the right-hand side we have little X's. What this allows us to do is hide a specific build configuration. Now we can see that up here we have a label that says no hidden build configuration. But as soon as I click this X box, what will happen is that now I will have the label updated saying that there is one build configuration that's hidden. In order for me to show that again, I just hover over to the drop down button and click show. So at any time I can now have a series of visible projects and only display from those visible projects the build configurations that I'm interested in. Additionally, we can also hide successful configurations. We can see here that we have multiple build configurations and the result of the last run of each build configuration varies. Here we see that everything has passed, here we see that things have failed. If I only want to see those that have failed, I can click on the checkbox, hide successful configurations, and that will hide it for me, displaying only those that have not been successful. At any time, we can just select all of them again by unchecking the checkbox. So very easily, we can customize Teamcity so that it only displays the information we want by configuring the visible projects and the build configurations we're interested in. Previously, we saw that a project can consist of multiple build configurations. Here we can see that the Kotlin compiler has multiple build configurations, and in particular we see that the compiler and plugin build configuration at the top. Now, the status of a build configuration is determined by the result of the latest build for that build configuration. In other words, here we can see that the compiler and build configuration is green because the last build that was run was successful. In addition, we can see that there's a current build running for this build configuration with an estimation of the time left on the right hand side. At any time, if we want, we can stop a build from continuing by clicking on the stop link and providing a reason. We can now see that the indicator has turned red and indicating that that build had been stopped. Here we can see that there is another, here we can see the k-annotator build configuration resulting in a failed build, and therefore it is in red. At any time we can start a new build by clicking on the run button, and as we do so, builds are added to the queue. Here we can see that this build configuration is now queued. If we click on the build queue, we can get a nice overview of all of the current build configurations that are queued. Anytime we can remove a specific build configuration as well as reorder the queue by simply dragging and dropping the item we want. An indicator tells us estimated time left for this build to start, etc. Going back to the projects page, we can click on a build configuration and get more insight into that actual configuration. You can see here that, for instance, there are no pending changes for this build configuration to run. The current status is that it's running, and recent history for the build configuration. If we click on the History tab, we can see in more detail the history for that build configuration. From here, we can jump to a successful build as well as a pin build. Now, what is a pin build? Well, Teamcity regularly performs cleanup of build configurations, deleting some of the older builds. If we want a build configuration to remain and not be deleted, we can pin it by simply clicking on the pin. This is required. And clicking pin, and that will pin it and not delete it. A build configuration can also be paused. So for instance, if we go to actions and click pause build configuration, we can now pause this build configuration and it will no longer be triggered to run. In addition, we can also check for pending changes of a build configuration, enforce a clean checkout from version control, as well as investigate any issues with a specific build configuration. Here we have the history of another project. We can see that we can filter the builds by tags. So for instance, if we click on EAP, it will show us only those builds that correspond to the EAP tag. At any time, we can remove a tag by clicking on reset. Additionally, at the bottom of the history page, we can always subscribe to the RSS feed of builds. And we can also customize this by clicking on the customize link and selecting the builds as well as the type of authentication, etc. On the overview page, at any time we can click on the little right arrow next to the build configuration and select history, and that'll take us directly to the history page. Now let's examine one of these builds in more detail. First of all, if we look at the history table, we can see that apart from the number and the results of the build, we also have artifacts, changes, started, duration, the agent build was run, some tags, and the pin which we saw previously. Let's click on one of these builds and see what information it provides us. First of all, we see an overview page which gives us information about the result with a green box indicating that this was successful. If we had code coverage, it will also display at the bottom here, which in this case it does. And then we can see a series of tabs. One of them is changes, the tests, build log, build parameters, artifacts, and code coverage, which we'll look at in a moment. On the right hand side, we see all history, which will basically take us back to the previous page that we were on, as well as an arrow which indicates that we can navigate to the previous build. So if we click on that, it will take us to the previous build. In this case, we see that the box is red, indicating that this build failed. And at the bottom, we see some information about why it failed. Here's a build that's passed. Let's take a look at some of the other tabs. On the Changes tab, we see a list of changes that occurred in this build. For each of these changes, we can see a list of files that were related to this change. We can hover over the list of files and see which ones were added, which in this case were 2. We can see if any files had been changed in one of the builds. For instance, we can see here that there was 1 added file and 4 files that were edited. We can click on each of these and Teamcity will open it up, showing us a diff of the file from the previous check-in to the current one. We can also click on the test to see more information about all the tests that occurred during this build, and we'll dig deeper into tests in a different module. Let's switch over to the build log. Here we can see the output of the build, which basically means that every action in the build script that has generated some output will be collected in the build log. The best way to look at the build log is using the tree view, which allows us to collapse and expand different nodes. So for instance, the updating of the sources can be collapsed and expanded on the one node. We can immediately jump to the tail of the build log by clicking on tail, seeing only the end result and the tail of the build log. We can also highlight important messages, as well as download the entire build log. Back on the history page, we can also access some information directly from here. To begin with, we can click on the artifacts. Artifacts are basically the output of a build. This can be packages, this can be zip files, etc. Teamcity has native support for recognizing certain file formats, including zip files, XML, HTML, etc. So by hovering over the artifacts, I can actually expand the contents of the different files and navigate inside them. At any time, I can just click on an artifact to download it, and I can also access the artifacts by clicking on the build and selecting them from the artifacts page, where I can also download them all at one go. From here, I can also navigate through the different contents of the files. Back on the history page, we can see that we can also access changes directly from this page. Similar to what we saw on the Changes tab, we can just hover over the changes, look at the different files, and select the one we're interested in and see the diff appear in the browser. When it comes to tests, Teamcity offers a wealth of information about tests and to work with them. First of all, on the build configuration for each build, we can see the number of tests that have passed. As a build is executing, it will also update the caption to display the number of tests that are being executed and the number that are being passed at that time. Here we can see that it's running tests on the utrack sharp.specs, indicating the number of tests that have passed and the one that is currently running. On the overview page, we can see the number of tests passed again, as well as some information about coverage if there happens to be some, as well again at the bottom seeing the number of tests that have passed. Now let's click on the Test tab. Here we can see in more detail information about every single test that has executed. It is important to know that Teamcity offers support for many different types of unit testing frameworks, and based on the unit testing framework, and based on this, different text can appear here. So we can see that we have a bunch of tests here that are being executed. along with the order in which it's executed and the duration. The value in brackets represents the current scope of this test. In essence, it's saying that this test belongs to utrack_sharp.specs.bugs namespace. If we click on this, what will happen is that Teamcity will filter it down to only that scope. A new line appears at the top indicating that we're currently in the scope of utrack_sharp.specs.bugs, and if we click all, we get all of the tests back. We can click on any of the columns at the top to change the sort order of the tests. Here we can see that tests are ordered based on how long they've taken. We can click on order and show it in the order of execution. Click on the test to show it in the order of the actual description of the test, etc. Let's click back on the duration and let's click on a graph. When we do this, what happens is that Teamcity loads the test duration graph for us, indicating over a period of time how the tests have performed in terms of time. We can click on the average checkbox to get an average of the execution time for these tests over a period of months. On the code coverage tab, we can see information about code coverage for the tests. Here we can see first of all a summary where it indicates the percentage of code coverage for classes, methods, statements, and then a breakdown of code coverage. Let's select one of these namespaces and it will drill us down into that namespace. For instance, we can click on issue management and issue management will show us the file issuemanagement.cs, and the green lines indicate where the code has been covered and the pink lines will indicate where code has not been covered. Teamcity integrates with a variety of code coverage tools, including one that ships out of the box from JetBrains, which is called .cover. For .NET projects, it provides code coverage. Back in the code coverage tab, we can also sort code coverage based on the different columns, much like the tests. When it comes to failed tests, Teamcity also offers ample information in order for us to know what exactly has gone wrong. Here we can see the results of a previous build, where we had 1 new failed test, 65 that had been passed and 2 ignored. At the bottom we can see that we have 1 new failed test and again indicating 65 that had passed. Let's first click on the test tab. Here again we can see all of the tests, and if we click on the status we can order by tests that had passed as well as tests that have failed. At any time we can also filter failed tests, and clicking on this will take us to information about that specific test, which basically shows it to us on the overview page. We can now expand information about this test and see that Teamcity provides us with information about the stack trace of a specific failing test, so we can easily identify what the problem could potentially be. In addition, it provides us with information about who made the changes, and since this is an actual older build, it already tells us that this test has already been fixed in a more recent build. It also tells us where this test first failed. In addition to the user interface that Teamcity offers via the web for us to deal with failing tests, etc., we can also use our IDE to interact with the failing tests. If we go to the username in Teamcity and select My Settings and Tools, we can see that we have a series of plugins for different IDEs, including IntelliJ, Eclipse plugin, Visual Studio plugin, etc. We now have Teamcity plugin installed into Visual Studio, and we can see that a new menu item appears. We can click Teamcity and select Login, provide our login details, hit OK, and this will now log into Teamcity. Once we're logged in, we can go back to the menu and select My Changes, and we can see that now it displays issues that have occurred in the build. In particular, we can see that we fixed the tests, but we seem to have broken some other ones, etc. If we right click on these tests, we can open the build log, open failed tests, or open in a web. Let's select open failed tests. We can see that we now have our failed tests displayed here with the stack trace, and we can also run these tests, etc. Going back to My Changes, we can also open this in the web. On doing so, we can see that it displays the overview page for us with 65 tests passed and 1 failed. So if we click on the arrow next to the failing test, we can select Investigate Mute. Now, what exactly does this mean? Well, let's first start with the mute. Mute basically means that we know that this test is failing and we know that the result of this failure is causing the build to fail. We're not going to do anything about this for now. We want to mute it and we're going to say no longer fail the build because of this failing test. And you can unmute this obviously when the test has passed successfully or on a specific date or manually. But what we're going to do is investigate. And what I want to do is investigate why this test is failing. And once the test has passed, I want Teamcity to automatically mark this investigation as resolved. So I'm going to hit save. And now I'm going to switch back to my ID and solve the problem. In this case, we're going to solve it by eliminating the test because we can say that, for instance, this test was no longer required because this was some older code. So we can remove that part of the test. And we will now check in the changes. We've now checked in the changes and Teamcity is now running the build. We can see that up here next to the label it says that we have one investigation pending. If we click on it, we can see that it shows the investigation. The build has now completed and we can see that all tests have passed and we no longer have active investigations. Teamcity offers code coverage and information about duplicates in code and code inspections. Let's take a look at these. First of all, in the Overview tab, we can see a summary of these different aspects of the code. In particular, we can see the code coverage summary where we have, in this case, 57.9% of classes covered, the same methods, statements, and we see some lines about duplicates and code inspections. We can click on the full report and that would be the same as clicking on the code coverage tab. So let's go ahead and do that. And it now shows us the full report for the code coverage. Here we can see the overall coverage summary as well as a coverage breakdown. We can sort by the different columns. We can click into each of these and find the namespace and the files where it shows us the coverage for that specific class. Where it is green, it means that the code is covered. Where it is pink, it means it's not covered. Back on the summary page, we can see the statements, percentage, methods, classes once again. And of course, we can loop through all of the different builds and see the code coverage progress over time. Teamcity also allows us the possibility of detecting code duplication during a specific build configuration. By enabling code duplication detection in either Java or .NET code, Teamcity will analyze our source code and see if it finds specific sections of code that can potentially be duplicates. When we have duplication detected, the duplicate tab will be enabled and we can click on it, and there on the top we can see the scope, which is referring to the path where code duplication has been detected, duplicates that it's found, and the instance lists. At the bottom we can see the two different files. In this case we see that the URL parsingbug.cs file on line 6 and 27 there is potential code duplication. Now if we actually scroll through this, we can see that yes, up to around 95-96% of the code is actually duplicated. However, the setup for the test is a little bit different, as is the actual result. And this is quite common because a lot of times tests can be exactly the same in terms of code, but the input parameter is different. So while this could be assumed as a false warning by Teamcity saying that this isn't actually the same code, it is nonetheless a good indication that maybe there's a different way we can approach this. Maybe instead of having two exact similar tests with different inputs that are mapping to different bugs, maybe we should do row testing, have the same code and have different inputs. So again, while duplication is detected, and often it is not warranted by Teamcity saying that it's duplicate, it is a very good indicator that there potentially can be a problem of code duplication in our code. Teamcity combines the power of IntelliJ's inspections for Java as well as ReSharper's inspections for .NET and enables us to run these on the server. In essence, providing us with a mechanism to detect any code issues during a build. Here we see an example of running code inspections on a C# project, and this is configured by the build configuration administrator, who can enable a step which is code inspections and define either to use the code inspections that default ReSharper provides or IntelliJ provides, or a specific file with inspection configured which has been checked into source control. Here I'm using the default, and we can see that Teamcity has detected a series of issues in our files. We can select a specific scope and then drill down to see the actual problems. On the right hand side we see the actual file. So here it's indicating that, for instance, a method getFileContentType can be made static. In line 71 it is showing us that a method addPrefixBar can be made static, so on and so forth. You can also select inspections based on the type of inspection as opposed to the actual file or namespace it's in. So for instance, if I click at the bottom here in consistent naming, it will show me that there are 3 constraint violations and then take me to these files. Now the build configuration can also be configured so that if there is a certain level of inspections, then it can make the build fail. If we don't want the build to fail, we can simply use this as a report to take a look at the inspections of that code and see if there's any potential problems. If we take a build and click on the change log, we can see a list of all of the changes that have occurred in that build, where we have information about the description that was entered when committing to version control. We have information about who made those changes, the files associated with that change, the header for the version control, in this case git is GUID, and the time and date. Now we can filter the changes by specific user. So for instance, I can select changes by Hadi or select all users. I can also filter changes based on a specific path. So for instance, I know that my tests are under the path specs, and I can filter by those, indicating only those changes that have to do with specs. We also have a series of options at the bottom. One of them is show graph, which is useful for version control systems that are distributed such as Git or Mercurial. Here we can see, for instance, that we've made a branching of a specific feature and we've merged it back in. We can also click on show builds, where it will show the build information, including the tests passed, tests that have failed, etc. And we can click on show files. Now before doing that, we can always access all of the different files for these changes by hovering over the files column and selecting all of the different ones. But if we click on show files, what it will do is place these files embedded inside the actual page. So we no longer have to hover over, only indicating the number of files that have changed. We can click on any of these files, and what happens is that Teamcity opens up the diff viewer inside the browser where we can see the changes, where we can select whether we want to ignore white spaces, copy to clipboard, open an IDE, etc. Last but not least, we can also download a patch of a specific file or the changes and save it to a location and then use that patch. Or if we have the corresponding Teamcity plugin installed in the different IDEs, we can click to download the patch to the IDE. We can also do this operation from inside an actual IDE. With Teamcity, instead of having to browse through the changelog to detect our changes, we can easily do that by clicking on the My Changes link at the top. If we do this, what Teamcity would display is our changes. However, for that to happen, we need to configure something in Teamcity. Now, in the module that covers settings and user profile, I've shown you how to configure this, but essentially what is required is that we map the username that we're using in our VCS to a specific user that we're logged in with on the Teamcity. Assuming that we have the user mapped, we can then click on My Changes and see all of the changes that we have made in all the different projects that we belong to. Here we can see in the first tab all of our projects, And then on each tab, we can see all of the different projects that we belong to. So I could click, for instance, UTrack Sharp and see all of the changes for UTrack Sharp. We can expand or collapse each change and see the builds that it belongs to, the tests that have passed, the tests that have failed. From there, again, access the build log. You can also click on the commit to see in more detail information about the changes, the problems, the tests, the builds, files, etc. On the right-hand side, we see a graph which gives us information about our impact with our changes on the project. We can click on the what do the colors link mean to see information about this graph, where red would indicate that a build failure with new problems has occurred. Dotted red would be build failure without new problems, and so on and so forth. If we have the plugin installed for the different IDEs, which we support IntelliJ, Visual Studio, Eclipse, we can select a specific file and click to open an active IDE. If we do this, what it does is then open the file in the IDE, so we can switch over and immediately see it there. Obviously, we can also see the file still in the browser by selecting it and seeing the diff in the browser. From within the IDE, in this case Visual Studio, we can also select the Teamcity entry and click on My Changes. From within the IDE, in this case Visual Studio, once we've logged into Teamcity, we can also select My Changes. From here, Teamcity will also display all of the changes that we have made for this project. So we can see here that we have different changes made, and we can select all of these ones and see all of the changes made for them. And from each of these entries, select to open the build log or open in web. If we click on open build log, it will show us the log inside Visual Studio. We can also select open in web to see the actual build inside the web. So whether we're working from within the IDE or from the browser, we can always see our changes easily. Often changes haven't been applied, and Teamcity displays these changes or pending changes for us on the main page of the build, where we can hover over the drop down arrow to see a list of the different changes that are pending. We can see that the changes are grouped by the actual user. So for instance, we see that Vladimir has some changes pending with 5 files, and then Andrei has a whole bunch of other changes pending with the different files. If we click on the actual link, we can see this in more detail. And from here, much like when we saw the changelog, we can show the graph, show the files, as well as download the patch or open in the IDE, and also run the build with this change. Normally in our workflow, we're going to make some changes to our code, check in those changes, a Teamcity build configuration will run the tests, and then give us green if everything is passed or red if something has failed. Now the problem is that if we are doing some experiments, or for whatever reason we don't want to bother other people of the team, and we check in some changes and it breaks the build, it leaves us with a headache and other members of our team, and we have to quickly revert the changes or in a rush try and fix what we've just broken. What would be great is the ability to actually check in some changes and have Teamcity run the build configuration without affecting other people. And that's effectively what Teamcity enables us to do with the remote run and the pre-test commit options. Here I am in IDEA, and I have installed the Teamcity plugin for IDEA. Now, I'm showing you the example in IDEA, but this is also supported in Eclipse and Visual Studio. At the bottom of our screen, we can see a Teamcity tab, and here I can see the projects, I can see my changes and my investigations. And there's a button here that says that I'm logged out, so I can log in again. I can also access this from the menu by Teamcity Login. So let's go ahead and log in, where I provide the URL, username and password, hit OK, and now it's logging into Teamcity. Now Teamcity supports personal builds and pre-tested commits with Subversion, Perforce and TFS. These are all centralized version control systems. With distributed version control systems, personal builds can be simulated using what's known as personal branches or feature branches. We're going to be focusing here on centralized version control systems using the remote run. Now, once I've logged into Teamcity, what I'm going to do is go ahead and make some changes. Welcome to the server. And I'm going to save that. And the next step is to go to the Teamcity menu and hit remote run. And this will bring up a dialog box where it shows me the files that I've modified. So it's very similar to the idea check-in dialog box. And in fact, it is the same, except that here the option is remote run and I don't have any other options, and the cancel. Now, let's just go ahead and cancel that. And let's invoke the commit dialog box in IDEA with using Control K or Command K shortcut, and we can see that it's basically the same box. The only difference is that now in the commit, I also have the option to commit and now remote run. So let me go ahead and click remote run. Once I do that, Teamcity now sends back the configurations which are valid for this project. And here we have the URL build trigger. Now let's examine this dialog box a little bit. At the top, I have an option to open in the browser, which means it will open this build configuration in the browser. I also have an option to customize, which I can also access by right-clicking and selecting customize. If we do that, we can specify the agent that we want this to run on, configuration parameters, system properties, environment variables for this run, etc. We can even place it at the top of the queue. Let's go ahead and cancel that, and let's look at some of the options at the bottom. Now, apart from doing a remote run, which is basically a personal run on the server, we can also have the option to tell Teamcity that if this personal run is successful, then commit the changes. That means first do a personal run, not affecting other people, and if and only if it is successful, then you can actually commit the changes to source control. That is why it's important to tie this option with actual source control. So I'm going to uncheck that and I'm going to click submit. The remote run has now been set off, and once it's complete, Teamcity is going to notify me of what occurred. I can select my changes and I can see that it's showing currently now that it's running and showing the progress over here. I can open this at any time in the browser. We can also see that this is a personal run by the little icon that appears next to the status bar of a person, showing that this is a personal run. If we click on the actual build configuration, we can see that it's showing the progress here, and we can see the previous builds. Now notice that I've already had a personal build here, again because of the person next to the icon showing that this failed. To all effects, this is exactly the same as an actual build that is like all of the ones below, with the difference that it is mine. That means that nobody else can actually see this build unless, of course, they specify that in their profile. If we go to our profile settings and tools, the option show all personal builds will mean that I will be able to see the personal builds of other people. Going back to the page, we can see that now this last build has passed. Everything is okay. We haven't actually broken anything. So all great. Now we can come back to our IDE and we can see that Teamcity has now notified us that the personal build was successful. So we can at this point make a check-in and a new build will run, and this time it will be public for everyone and it will be green. Alternatively, instead of doing this in a two-step process, as I mentioned before, we can just commit and select remote run and select commit after build finish. So what this means is that it will do the exact same thing, except this time it will also commit the changes if the tests have passed. In addition, under my changes, we can also see these builds. We can commit, view changes, remove, again open in browser. And also Teamcity via the plugin provides support for code inspections, duplicates, and code coverage. Normally in our workflow, we're going to make some changes to our code, check in those changes, a Teamcity build configuration will run the tests, and then give us a green if everything is passed or red if something has failed. Now the problem is that if we are doing some experiments or for whatever reason we don't want to bother other people of the team and we check in some changes and it breaks the build, it leaves us with a headache and other members of our team. And we have to quickly revert the changes or in a rush try and fix what we've just broken. What would be great is the ability to actually check in some changes and have Teamcity run the build configuration without affecting other people. And that's effectively what Teamcity enables us to do with the remote run and the pre-test commit options. Here I am in IDEA and I have installed the Teamcity plugin for IDEA. Now I'm showing you the example in IDEA, but this is also supported in Eclipse and Visual Studio. At the bottom of our screen we can see a Teamcity tab, and here I can see the projects, I can see my changes and my investigations. And there's a button here that says that I'm logged out so I can log in again. I can also access this from the menu by Teamcity Login. So let's go ahead and log in where I provide the URL, username and password, hit OK, and now it's logging into Teamcity. Now Teamcity supports personal builds and pre-tested commits with Subversion, Perforce and TFS. These are all centralized version control systems. With distributed version control systems, personal builds can be simulated using what's known as personal branches or feature branches. We're going to be focusing here on centralized version control systems using the remote run. Now once I've logged into Teamcity, what I'm going to do is go ahead and make some changes. Welcome to the server. And I'm going to save that. And the next step is to go to the Teamcity menu and hit Remote Run. And this will bring up a dialog box where it shows me the files that I've modified. So it's very similar to the IDEA check-in dialog box. And in fact, it is the same, except that here the option is Remote Run and I don't have any other options, and the cancel. Now, let's just go ahead and cancel that. And let's invoke the commit dialog box in IDEA with using Control K or Command K shortcut, and we can see that it's basically the same box. The only difference is that now in the commit I also have the option to commit and now remote run. So let me go ahead and click remote run. Once I do that, Teamcity now sends back the configurations which are valid for this project. And here we have the URL build trigger. Now let's examine this dialog box a little bit. At the top, I have an option to open in the browser, which means it will open this build configuration in the browser. I also have an option to customize, which I can also access by right-clicking and selecting customize. If we do that, we can specify the agent that we want this to run on, configuration parameters, system properties, environment variables for this run, etc. We can even place it at the top of the queue. Let's go ahead and cancel that, and let's look at some of the options at the bottom. Now, apart from doing a remote run, which is basically a personal run on the server, we can also have the option to tell Teamcity that if this personal run is successful, then commit the changes. That means first do a personal run, not affecting other people, and if and only if it is successful, then you can actually commit the changes to source control. That is why it's important to tie this option with actual source control. So I'm going to uncheck that and I'm going to click submit. The remote run has now been set off, and once it's complete, Teamcity is going to notify me of what occurred. I can select my changes and I can see that it's showing currently now that it's running and showing the progress over here. I can open this at any time in the browser. We can also see that this is a personal run by the little icon that appears next to the status bar of a person, showing that this is a personal run. If we click on the actual build configuration, we can see that it's showing the progress here, and we can see the previous builds. Now notice that I've already had a personal build here, again because of the person next to the icon showing that this failed. To all effects, this is exactly the same as an actual build that is like all of the ones below, with the difference that it is mine. That means that nobody else can actually see this build unless, of course, they specify that in their profile. If we go to our profile settings and tools, the option show all personal builds will mean that I will be able to see the personal builds of other people. Going back to the page, we can see that now this last build has passed. Everything is okay. We haven't actually broken anything. So all great. Now we can come back to our IDE and we can see that Teamcity has now notified us that the personal build was successful. So we can at this point make a check-in and a new build will run, and this time it will be public for everyone and it will be green. Alternatively, instead of doing this in a two-step process, as I mentioned before, we can just commit and select remote run and select commit after build finish. So what this means is that it will do the exact same thing, except this time it will also commit the changes if the tests have passed. In addition, under my changes, we can also see these builds. We can commit, view changes, remove, again, open in browser. And also Teamcity via the plugin provides support for code inspections, duplicates, and code coverage. Next to our username, there is a drop down where one of the entries is My Settings and Tools. Now this is the user profile section of Teamcity, and it allows us to specify certain things in our profile as well as specify roles that we have in different projects and notification rules. The first thing we notice is a general tab, and under here we can specify the username, our full name, email address, enter a new password and confirm password if we want to make changes. One of the important settings here is the version control username settings. Now, when we're working with my changes or when we're trying to associate a specific user that has made a change in version control and associate that user, map that user to a Teamcity user, this is where that setting is set. By default, what Teamcity does is take the username that you have in Teamcity and use that same one. It will assume that that's the same one that you have in your version control. If you want to change that, you can click edit, and then you can change it for each of the VCS routes, or you can specify it for all VCS routes, the default. So in this case, I can say, for instance, that my VCS user is also called demo user. Let's say, for instance, that I'm working with Git. What I could do is add a new VCS username, and I could say that default for all Git routes will be my email address. So I could map this to my email address. So what happens now is that a new entry is created that is going to be the default for all Git routes. This means that when a project has a VCS of type Git, Teamcity is going to try and map changes, identify my changes from those that are done by mail@hadihariri.com when checked into version control. Back on the main page, another setting that we're interested in is the highlight my changes and investigations. If checked, what happens is that our changes are highlighted as well as our investigations. The show date time in my time zone allows Teamcity to display the date and time relevant to our own specific time zone. And last but not least, show all personal builds is to display all personal builds in our timeline. One of the main things that we can configure under the profile is the watched builds and notifications. Now, Teamcity, when a build fails or when a build succeeds, sends out notifications, and these notifications can come in different flavors. It can be an email, it can be IDE notifier, a Jabber notifier, or the Windows tray icon notifier. What we can do here is configure these. Now, if I click on edit, for instance on the email notifier, takes me to a screen where I can add notification rules. And if you notice that this notification tab is actually the same as we had here. So I can click edit from any of these or click on the notification rules at the top and then select the corresponding notification from this tab. Let's go ahead now and add a rule and see how it's done. If we click on add new rule, Teamcity will now display a series of conditions that we have to configure for that rule. To begin with, we can specify what we want the rule to watch. Would it be builds affected by our changes, or for instance builds from a specific project, or builds from specific projects and selected configurations? We can filter here For instance, we can write plugin and it will show us anything related to plugin. We can also say just watch system-wide events. That means pretty much anything. Let's change back to builds affected by my changes. And now let's see the different options for sending notifications. Now Teamcity can send notification when a build fails. We can then specify to ignore failures that are not caused by our own changes or only notify us on the first failed build. So what we don't want to do is constantly get notifications of failed builds. We can also say to notify us when a build is successful, and again only notify us on the first successful build. Other options include the first build error occurs, when a build starts, when builds fail to start, when build is probably hanging, an investigation is updated, or when tests are muted or unmuted. Now, as a typical user, as a typical developer, we normally aren't interested in a lot of these areas. This would be more like a system administrator would be interested in that. Once we've defined the rule, we can then click save and that rule will be added. Now, it's important to know that rules are processed top down and the first one that matches is applied. Also, rules are inherited. So if there are rules defined in the group or users, then those rules are also inherited for us. Adding rules as an IDE notifier or Java notification or Windows tray notifier is pretty much the same process. I can click, for instance, Windows tray notifier and here select add new rule, and the options are pretty much the same. The difference is that we can have different rules for different notification mechanisms. This is actually very useful. For instance, I want to receive a notification as a pop-up tray icon in the Windows tray notifier every so often when a build fails or is successful, and it doesn't really bother me. It's just a little balloon that pops up. On the other hand, I don't want to be so explicit about notifications in terms of emails. That is, I don't want my inbox to be flooded with notification emails about a build being successful or failed, etc. So we can have different rules based on the notification, which comes in quite handy. Back on the general page, on the right hand side, we see that we have the Teamcity tools. Now from here, we've seen that we can install some of the different plugins for IntelliJ platform, Eclipse plugin, Windows tray notifier, or the syndication feed. And if we want to install something, we can just click download, save it, and install it. The syndication feed allows us to customize the actual RSS feed, which we've seen that is also accessible from the bottom of any build history page. There's also a NuGet feed, which allows us to obtain information about the NuGet URL if we have that service activated. Last but not least, under My Settings and Tools, we can also get information about the groups that we belong to, as well as the roles that we have. So here I can say that demo user is assigned to one group, which is all users that contain all Teamcity users. And if I click on roles, I can see the different roles that I have. So we've seen that under the settings and tools, we can configure general information, configure the notifications and builds that we want to watch, download Teamcity tools, and do everything that's related to our user profile for the Teamcity user.